Good afternoon, everybody online. Can you hear me? Can you see the screen?
Yes, sir.
That's a yes. Can see the screen?
Yes, sir.
All right, good. So I've been forced offline today because of you know what. And this is why we cannot pass up on the opportunity to keep classes. Because you just never know when something's gonna happen, cause us to, like cancel a class or put up a class. Fortunately, we now have online modality that we can use. All right, we're gonna do that today. Today was meant to be a classwork day where you would do the classwork in the class and get it right before you leave. I don't yet know how I'm gonna do that online. What I might have is persons do the work and send it to me directly, stuff like that. But I'll see. But still want to get through the practicing of some of these circuit theory questions. I just sent something to the group, which is a must know item for this topic. Something I should have said before. All right. So what I'm going to do, I'm going to start out with a little recap of the 7 rules that you're supposed to know. And I'm also going to write the way that you're supposed to write the rules in a question. All right. So let me do that first. All right. That's a quick recap of the 7 rules that you're supposed to know. You will not be able to do this topic unless you absolutely know those rules. All right. So you have to take time out to ensure that you learn the rules. All right. So let's remind ourselves of the rules. So I've gone through them already. Now I'm just going to say them. And I'm also going to write what you are supposed to write on the paper. You don't need to be reinventing the wheel. Right? You just need to write your responses the same way every time. That way in an exam room, you will just flow. You're not trying to figure out what to write. And sometimes if you try to put it in your own words and try to formulate the rules and the reasons yourselves, you might just say something that is not true and lose the marks. The best way to do it is just learn a particular way to write them. Is only 7 of them, and write them the same way every time. That way you're guaranteed your marks. All right? So the first rule we mentioned was what we call the center rule. And the center rule basically says angle at center is twice angle at circumference. All you need to write. So what I'm putting in red is what you need to write when you're using that rule as a reason for an angle. Right? Angle at center is twice angle at circumference. Angle at center. So we're talking about a circle. It's twice angle at the center. Sorry, angle at center is twice angle at circumference. Relax now, relax now. Hey, relax, I want to go outside, relax. Angle at center is twice angle at circumference. Remember, an angle is either subtended by a chord or subtended by an arc. An angle is either subtended by a chord or it is subtended by an arc. Okay, so that's rule number 1 that we looked at. I'm going to do some examples today and we're going to be using these rules. So the second one that we looked at was what we call the diameter rule. Pertains to angle subtended by a diameter. So we call it the diameter rule. And this one is quite simple. It is that the angle subtended by a diameter is 90 degrees. Angle subtended by a diameter is 90 degrees. Sometimes they call it the semicircle rule because angles in a semicircle is 90 degrees. All right, so angle subtended by a diameter is 90 degrees. All right. And I'm saying this is all you need to write when you use that rule. But I've been red. All you need to write when you use that rule. Third rule we dealt with was the same segment rule. Rule number 3. Call it the same segment rule. You have your devices? All right, let's log in. Log on. Same segment rule. The same segment rule is that angles in the same segment of a circle are equal. That is when they are subtended by the same arc or subtended by the same chord. Angles in the same segment are equal. So when you use the rule, this is all you need to write. Angles in the same segment are equal. Angles in the same segment are equal. That's all you need to write when you use that rule. The fourth rule we looked at was the cyclic quadrilateral rule. The cyclic quadrilateral. And two things about a cyclic quadrilateral are two things will happen for you to have a cyclic quadrilateral. One, if you have a circle and a quadrilateral is in the circle, all 4 vertices on the circumference of the circle, then that quadrilateral is cyclic. And when it is cyclic, the opposite angles are supplementary. So those two would add up to 180 degrees. That's what supplementary means. They add to 180 degrees. And these two, again, would be supplementary. Mute the mic, please. They would add up to 180 degrees. All right? That's one way you have a cyclic quadrilateral. Now, if you just have a quadrilateral randomly, and that quadrilateral is such that the opposite angles, so these two angles that are opposite each other, let's say they add to 180 degrees, then that is a cyclic quadrilateral as well, simply because the opposite angles add to 180 degrees, even though there's no circle there. It means that it is possible to fit a circle on this quadrilateral passing through the 4 vertices. It's possible. All right? That's what happens in a cyclic quadrilateral. So you don't need to have a circle on a quadrilateral for it to be cyclic. Once the opposite angles are supplementary, it is cyclic. Once the opposite angles are supplementary, it is cyclic. All right? A key thing about the cyclic quadrilateral, when you're writing the rule, you have to use the word opposite. So you have to say the opposite angles in a cyclic quadrilateral, or you can say cyclic quad. I'm showing what you can write on the exam. If you write cyclic quad like that, they'll give you the marks. Opposite angles in a cyclic quad are supplementary. And supplementary, remember, means that they add to 180 degrees. So instead of saying that they are supplementary, you can say they add to 180 degrees. So you can use any one of these two. You can use the word supplementary, or you can write out that they add to 180 degrees. But the key thing when writing this rule is to remember to put the word opposite there. If you don't put the word opposite there, you're not telling the truth. If you just say angles in a cyclic quadrilateral are supplementary, that is not true. But if you just say angles, you mean that you're talking about all of them. You have to specify that it is the opposite angles that are supplementary. Everything is important. We are all familiar with saying angles in a triangle add to 180 degrees. And so you tend to want to say the same thing here. All right? So get into the habit of making sure that you put the word opposite when you're talking about the cyclic quadrilateral. All right, so the fifth thing we mentioned, or the fifth thing we did in class was tangent and radius rule. Tangent and radius. That's the angle between a tangent and a radius. This one is pretty easy and straightforward and kind of makes sense and very obvious. The angle between them is 90 degrees at the point of contact. The angle between tangent and radius is 90 degrees. We know we're talking about at the point of contact, but if you just write this in the exam, you get the marks. That's enough for you to get the marks. All you write is just that you will get the marks. So we're going 5 so far, 2 to go. Next one, mute the mic, please. Somebody's mic is open. Mute the mic, please. The next one, number 6, is what we call the two tangents rule. Right? This is when two tangents are drawn to a circle from a single external point. We call it two tangents. Mute your mic, please. Mute your mic. Let me see if we can do this. You have to keep your mic muted, please. All right. So the two tangents rule. Two tangents rule. Now, there are a number of things happening here in the two tangents rule. Two tangents from a single external point are equal in length. You can only have 2 of them, one on either side of the circle. Any way that one of them relates to the circle, the other relates in the exact same way. So the first thing is that they are equal in length. But one of the main things to remember about the two tangents from a single external point is that the two tangents together with the two radii, they form a cyclic quadrilateral. The opposite angles are supplementary. So that's the main thing to remember about the two tangents from a single external point. So I'm going to write it like this. The two tangents and the two radii they form a cyclic quad. We'll show this in class, right? This is just revision. With opposite supplementary angles. Opposite supplementary angles. All right? So if you have a circle, and you have two tangents from a single external point, and your complete quadrilateral to the center with the two radii. Remember now that the angle between the tangent and the radius is 90 degrees. That's from rule number 5. So right here, 90 degrees. This tangent and this radius again is 90 degrees. So it means that these two angles opposite each other add up to 180 degrees. They are supplementary. And so the total angle in the quadrilateral is 360. Means that these two angles will always add to 180 degrees. All right? And oftentimes in questions, the two tangents of a single external point, they will, for example, tell you that this one, let's say they tell you that this one is 40 degrees. And they're asking you for this one in here. You must know that that one then is 140 degrees because they must add to 180. And the reason would be that this thing is a cyclic quadrilateral. So how I would write this rule if they give me this diagram. Let's say I put some letters on this, and this is AOBP. So instead of saying the two tangents and the two radii, I would just, instead of writing out all of this, I would just use AOBP. I would say AOBP forms a cyclic quadrilateral with opposite supplementary angles. That's why these two angles are supplementary. All right, so that's how I would write this rule in an exam question when they give me the points on that quadrilateral, AOABC, AOBP. All right, so that's how I'd write that one. Then we'll come to the last one, rule number 7, which is about the angle between a tangent and a chord. So we call it the tangent and chord rule. Tangent and chord rule. That one says the angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segment at the circumference. Well, some teachers call this the alternate angle rule, which is fine. Right? So how that one works, remember, is that if you have a circle and you have a tangent to the circle, and then that tangent is making an angle with a chord, and let's say that the angle between here, between this tangent and this chord is known, and let's say that angle is, just give it an angle now, let's say 20 degrees. It means that this chord now itself is going to go and subtend same 20 degrees at the circumference over here. That's how it works. Angle between the tangent and the chord is equal to the angle subtended by the chord at the circumference in the alternate segment. All right? And sometimes in the questions, what will happen is that you will be given, sometimes you will be given the angle up here, and you're required to know that it is equal to the angle between here. You have to know the rule both ways. You have to know it going from this angle to this. You also have to know it going from this angle to that. You have to know that those two angles are equal. Whichever one you get, you know the other. Right? Tangent and chord rule. So you have to take time to learn the rules. All right? There's no getting away from it. This one said, how do you write this question? You can say angle between tangent and chord equals angle subtended by the chord. Remember, guys, I don't want anybody to go about trying to construct their own way of writing these reasons, because you just might say something wrong. Just learn these ways and write them the same way every time. Once you use the rule, write the rule that way. All right? There's no need to go trying to learn some other way. If you find another way in a book or another teacher teach you another way to write, to say it, you can go ahead and use that other way once it is correct. Like some teachers use for this rule, they call it the alternate segment rule. And they describe it using the term, write it in terms of the alternate segment, and they state the alternate segment in their expression. So that is fine. But the point is, don't go trying to construct your own way of saying it. There's no need to do that. Right? Use one of these established ways of saying it and just say it that way every time you do it. It makes your work faster. You go through the question, you know that you are correct, right? And there's no need to go about wondering if what you said is correct, because you just might say something in it that is not right. If you put one word in it that is not right, you're not gonna get the marks. All right. So this, you can screenshot this, or it's something that I gave before in the class. It's the same thing I wrote again, if you notice. Every time I write these rules, I write them the same way. All right. So just to recap, we can look again at what I sent in the class. I sent this in the class. Sent this in the class group. Where is it? Right. So I sent these in the class group. All right. So basically that is it. So I sent this in the class group, and those are the 7 rules summarized there again. The first one again is a center rule. Second one is a diameter rule. They have the same segment rule. Let me see if I can get this up. I don't know. All right. Let me see what I can do. I can mark on this. Can I mark on this? Let me do something else. Okay, I mark on this. Let me see if I can use a different app to this thing. Okay, mark on it. I don't know what to do. I don't know what to do. I'm not a techie like you guys. We're gone.
You could try open it with a different app. That would probably work.
Yeah, that's what I was trying to do a while ago. So maybe like this one. All right, yes. So this one allow me to mark it, I guess. Good. All right. So this one over here is a center rule. That's it. So I sent you this document in the class. This one is a diameter rule. This one is the same segment rule down here. I see it is summarized up here. Angle at the angle at the center is twice angle at the circumference. So you can actually write the rule this way when you use it. This one says angle subtended at the circumference by a semicircle is 90 degrees. I say angle subtended by a diameter is 90 degrees. This one, same thing. But just establish one standard way of writing here. Angles in the same segment are equal. See? That's it. So I need to write for that one. All right. Then we have a cyclic quadrilateral here. See again, the key word there is opposite. See there, opposite. Opposite angles in a cyclic quadrilateral sum to 180. I could say they are supplementary. Then we have the tangent and radius. Here they say the tangents and radii meet at 90 degrees. I say angle between a tangent and a radius is 90 degrees. Same thing. And here we have the two tangents rule. Two tangents rule. Two tangents from a point of equal length. Right? But I added the one that I sent in the group, I added 2 radii to it. Like that. And I said that these two here and here add up to 180 degrees. All right, something like theta plus alpha equals 180 degrees. And that most times the questions require you to use that. All right. Then we have the tangent and chord rule. Right here, they call it alternate segment theorem. So some people call it alternate segment theorem. Right, but I prefer to write it out and say the angle between the tangent and a chord equals the angle subtended by the chord. Right, so the angle between this tangent and this chord, which is this angle, the chord subtends the same angle across there. And if it is this angle, this tangent, and this chord, and this is the angle, then the chord subtends the same angle across there in the alternate segment of a circle. All right, so those are the rules, guys. So we just need to practice them in order to learn them properly. All right. All right. I'm going to do a couple questions now. Today is supposed to be a class activity day. I'm going to do a couple questions from the homework sheet. And then my intention to give you a classwork to do. So you and you're going to do the classwork. People online, I put the classwork on the screen. And you do it and send it to me. Let me see. All right. But let us do a couple questions first. So let me mark the questions that I'm going to do. Mark the questions that I'm going to do. I'm going to do this one. Just before, I'm going to do that one. I'm going to do this one. Which one again? Which one again, Mr. Shaw? Which one again? Which one again? Which one again? Yes, I'm going to do this one. Oh, there's another one that I really want to do. I'm going to do this one. Woman equals better maths, and I will practice a lot. So, right. That's how many. 3 of them I'm going to do. I'm going to give you a couple of minutes to do this one before I do it. And there's another one I'm going to put up on the screen just to emphasize something. Right? It's not on this page. I'm going to bring it up on the screen and give you a couple of minutes to do it before I do it. And then I'll give you the classwork. All right? So I'm going to do like this one first. No, I'm going to do this one first. And then this, let me number them. I'm going to do this one first. This one second. I'm going to do this one third. After I give it to you to do, I'm going to do a 4th one. And then I give the classwork for you to do 2 for yourself. All right, so that is a plan. All right, let's go. Didn't plan to have this class online today at all. I'm kind of feeling my way through. Did not prepare our class, online class today. Did not prepare. All right, so we're doing this question that's on the screen right now. And I'll do it on the right side of the screen. All right, so this question gives us this diagram. And remember, every time you read information in here, you're looking to see if there's anything on the diagram that is not, anything that they mentioned down here that is not on the diagram. Anything they mentioned down here that is not on the diagram, I'm going to put it on the diagram. That way, you don't have to come reading anything down here again. You can just work on the diagram going forward. All right, so this question says, in the diagram not drawn to scale, remember this word, this term means you cannot go by how anything looks. You cannot go by how anything looks. You cannot use any instrument on the diagram. You cannot measure anything. You cannot put any tractor on it or anything like that. You have to use the theorems and so on to answer the questions. So this one says it's not drawn to scale. ABCT is a circle, all right? So that's a circle. It says AC and BT are diameters, okay? So these are diameters. So once you hear about diameters, you're supposed to be thinking about the diameter rule. Angle subtended by a diameter is 90 degrees, just in case you need to use it, right? It says TP is the tangent at T, so this is a tangent at the point T. And it says BA is produced. Remember, we introduced this word. Which topic we introduced? I think we introduced this word with the vectors. And the word produce means extended. Our length, see there, BA, this is the line BA, is produced, means extended out to P, right? extended, produced at P. BA produced, extended, or length out to P, so that this angle now is 40 degrees in here. So that's information. So everything that they have said is in the diagram. So we just need to work from the diagram. It says calculate given reasons for all statements, and the reasons generally are the 7 rules. But remember, all other geometry rules are valid. Like for example, Z angles, alternate Z angles are equal. Co-interior U angles add to 180 degrees. Total angles in a triangle is 180 degrees. 2 angles in an isosceles triangle are equal. I know which 2 angles are equal. The angles that are opposite the equal sides are equal angles. So those normal geometry rules still valid in addition to the 7 rules. So there are questions that you will not be using the 7 rules for your justification. You'll be using one of the regular geometry rules. Total angle on a straight line is 180 degrees. Those rules are valid as well. All right? So let's go. The question says we have to find the angle first. BTP. Where's that? Let's put it on the diagram and see how we're going to get it. Angle BTP. That's between those 2 lines. What 2 lines are those? Those 2 lines is a tangent and a diameter. Or we could say a tangent and a radius. And that is obviously 90 degrees, right? That's a tangent and radius rule. Tangent and radius rule. So you have to write out that now angle between a tangent and a radius is 90 degrees. So this angle right here is 90 degrees right now. Right? BTP. So it's basically the tangent and radius rule. So we can write it over here. Angle BTP equal 90 degrees. Then you have to write out the rule. Write out what I wrote in red. You have to write this out. This. Tangent and radius rule. This one. Angle between a tangent and a radius is 90 degrees. You have to write out that one as your reason. Because I'm on the device, I can actually copy it down. Let me see. Later, I'll just copy this one. So you have to write this out as your reason for this question. You put it here. So on the exam paper, they put somewhere for you to put your reason. That is it. Tangent and radius rule. All right? So that angle here is 90 degrees. Next angle, the one, this one, is angle BAT. Angle BAT, where is that? BAT. It's another 90 degrees, you know. So we're talking about this angle now. So I always tell the students, if you can't see what it is right off the bat, come back along the lines, forming the angle till you reach a circumference. And you look what is subtending the angle. An angle is either subtended by an arc or by a chord. So you find a chord that is subtending the angle, look what else the chord is doing and see which tool you're going to be using. Or it might be an arc. It's always easier to see the relationship when it's a chord, but you have to learn and practice how to see the relationship when the angles are subtended by arcs as well. All right? So what I would do for this question if I don't see it right away, or for this angle, if I don't see it right away, I'll come back along the sides that make the angle. So this side, I'll come back along this side until I reach a circumference, and come back along this side until I reach a circumference. I'm looking for a chord first. Chord happens to be a diameter. So the angle is actually subtended by this diameter. We're going to use the diameter rule. So that angle up there so is 90 degrees. Because angle subtended by a diameter is 90 degrees. So this angle inside here is 90 degrees. It's subtended by a diameter. All right? So we can write that. So for part 2, the angle BAT is 90 degrees. And we can copy down the diameter rule. The second rule that we have here. Angle subtended by a diameter is 90 degrees. That would be the rule that I'm using for this one. See there? Angle subtended by a diameter is 90 degrees. That's all I would write for that one. That's my reason. I get your marks. All right. So that is also 90. Next angle I want is this one. Angle ABT. Angle ABT. That's this one now. Angle A to B to T. It's this angle here I want next. That angle I want next. What I can see in this diagram, I don't know if you see it, but this angle that I want is an angle in this big triangle, which happens to be a right angle triangle, but this angle is 90. See that? This angle is 90, and this angle is 40. This angle has to be 50. Remember now, if this angle is 90, then these two must add up to 90. A total angle in a triangle is 90 degrees. And in a right angle triangle, two non-right angle triangles are complementary. They add to 90 degrees. So this angle over here has to be 50 degrees inside here, 50 degrees. But I can appreciate that online. But go do that.
Yes, sir.
Right, so this angle is going to be 50 degrees right here. It's going to be 50 degrees for the total angle in that triangle. So that's how you write up this one. You're going to say that angle B, we don't call it angle ABT. Angle ABT equals 50 degrees, but I want to show a little bit of calculation. I'm going to say it's 180 degrees minus this 90 and this 40. Minus the 90 and the 40, sum of them. That's how I get the 50. And my reason is that total angle in this triangle, I have to name the triangle. This is my reason now for this one. Total angle in triangle, name the triangle. PBT in triangle PBT is 180 degrees. That's how we use 180 minus 2 that we have to get the one that we just found. But I go so far? Easy question. Next one says the one angle ACT. Angle ACT. Now where is that? ACT. That's this angle inside here. ACT. That's right here. So what this angle now? You take this off. Now let's say that's what they have. I can't see what it is right away. Again, what I would do, what I suggest, is that you come back to find what is subtending that angle. It is subtended by an arc or a chord. So you go back along the lines forming the angle. Don't stop here. You go all the way back until you reach circumference, which is here. It is subtended from here. And you come back along this side until you reach circumference here. So this angle that you want now is subtended by this chord, or you could say it's subtended by that arc. You mark the chord in a different color, subtended by this chord. When you find a chord that is doing it, work with the chord first. Most time the chord is easier to work with. What else is the chord doing? Chord is also subtending an angle up here of 50 degrees. That's a same segment rule situation. Because this chord divides a circle into this minor segment and the major segment over this side. And these two angles are in the same segment, both of them subtended by that same chord, and so they are equal. All right? So this angle down here is also 50 degrees like that one. And it's the same segment rule. All right? Same segment rule. So this angle is 50 degrees as well. 50 degrees. All right? So for that one, I would say it right like this, that the angle that we want, which is ACT, is equal to the angle over here, which is ABT, equal to angle ABT, which is 50 degrees. Why is that? Angles in the same segment are equal. All left to right. Is rule number 3 on our paper. Same segment rule right here. Angles in the same segment are equal. So I would write this. right? We write rule 3, write out the rule, write it out. You have to write it out. We just call it rule 3, right? We put it in that sequence. 60 don't know it as rule 3, and they don't know it as rule 2. Our class we just call it rule 3 because the third one we introduced, right? But you have to write this out. You have to write it out what the rule says. All right, so that is it. That finishes that question. Everybody good? Online, everybody good? Everybody okay? Yes. All right, running good. All right, let's move on to the next one. We'll see what we're gonna do today, which is this one here now. All right, let's do this one. All right, so this one gives us this diagram. It gives us some information down here. I want to read the information to ensure that what they say is on the line. Now, looking at a diagram like this, when you see an arrow on this line and an arrow on that line, what does that mean? See those two arrows. Why did they put an arrow on this line and an arrow on this line?
They're
What did they?
Because they're equal.
Huh?
They're parallel.
No, because they are parallel. Right? So when lines are parallel, they put arrows on them. When lines are parallel, they put arrows on them. So look, if for example I have a diagram, let me do it over here. More things you know, the better. If I have a diagram, like this, like that, another piece of like that. What they might do to show that these two lines are parallel is put arrow pointing this way and an arrow pointing that way. So if there's another line in the diagram, like for example, if I take this now and I put another line up here, going this way, so that this line and this line also parallel, they might now put double arrows on this one. So they might put 2 arrows on this one now and put 2 arrows on this one. So the ones with the 2 arrows are parallel and the ones with the single arrows are parallel. But I get that? Now somebody said that these two were the equal length. No, that's not how they show equal length. They show equal length with strokes. So in this diagram that we have here, let's say that this length and this length is the same. Those two lines. I'm going to take off the arrows for the time being. Let's say that they are the same. To show that this length and this length is the same, they might put a single stroke on this and a single stroke on that. That now means that the lines are equal in length. If I extend this one, and let's say I take this one, shift this over a bit. Let's say I take this one and I extend it up. Let's say maybe up to here. So that this now and this now the same length. What they might do in that case, like look now. Let's say these two equal in length, and they put a single line on this and a single line on that. Maybe there are 2 other lines in the diagram that are also equal. I might put a double line on this one now, a double line on this, and a double line on this one, or a double stroke. So the ones with the single stroke are equal in length, and the ones with the double stroke are equal in length. All right? So arrows mean that the lines are parallel. Those little strokes mean that the lines are equal in length. Everything is important. The more things you know, the better. All right? CSEC just might give you a question, put the arrows on it, and don't tell you that the parallel. You have to know. All right. I remember also now, guys, once you're doing a question with parallel lines, your brain should automatically be thinking about Z angles and U angles. Where the Z angles are the alternate angles which are equal. The U angles, angles that we call U angles, are the co-interior angles that appear to be like a U. So for example, this one, what would be the Z angles? So you come up this parallel line, go down this one, and then up this one again. The angles inside here are equal. Those are the angles that are called alternate angles. appear to be inside the Z, right? Then now, if you join the base of the two lines, two parallel lines, so those are the two parallel lines, and you join them with this baseline here, you seem to have formed a U. And angles in the base of the U, they add up to 180 degrees. Those angles are called co-interior angles. They are supplementary. Once you have parallel lines, you're looking out for the Z angles, you're looking out for the U angles. All right? You're looking to see if you can use them, if there's a need to use them. All right, but let's get back to the question now. So it says in the diagram, not drawn to scale again, RST and TQV are tangents. So see, they are drawn from a single external point. So it means that these two tangents are equal in length. Those two tangents are equal in length. This line that connects them makes that an isosceles triangle, don't it? So this triangle now is an isosceles triangle. Let me zoom up on it a bit. All right, so that length and that length is the same. This line completes that triangle, which becomes an isosceles triangle. And in that triangle, we know this angle. And if you know one angle in an isosceles triangle, you are blessed. You can find the other two. This now, these two angles will be equal, right? They'll be equal. And since I know this one, it's easy to find those two. What I do? Subtract from 180 and divide by 2, right? So that angle, for example, will be 180 degrees minus the 110 degrees divided by 2. Because the total angle in there is 180, and these two base ones are equal. So when you subtract the 180, you're getting the sum of these two. Because they are equal, you divide by 2 to get each of them, which works out to be 35 degrees. So these two angles, 35 degrees each. All right, so you know that this angle is 35 degrees, this angle is 35 degrees. What is this angle? This angle, which is 35 degrees now, will be the angle between this tangent and this chord. Good? Tangent and chord. So it means then, since this angle is 35 degrees, then the chord is going to go and subtend 35 degrees up here. So this angle is 35 degrees. I don't start answering the question yet, but you're picking out some of these things. And then because of the alternate angle, this angle inside there now is 35 degrees because of the Z angle. So this is also 35 degrees. And you can see these things as you go, and you just answer the question, right? But those are just some angles you can pick up right off the bat. Before we go any further, what is this angle? It's subtended by this line. What is this angle right here? Huh? It's a 90 degrees. What is a 90 degrees? Online, what is a 90 degrees?
Yes, sir.
All right, so that is wrong.
Third first question, where's the origin?
Not the origin, the same in a center. All right, so the key thing to remember now, guys, I did this deliberately. Point out to you that you must never go by how anything looks. You look at a diameter, but they did not show you the center of a circle. If you don't know where the center of a circle is, you cannot say that that's a diameter. The question did not mention a center. So you cannot go assuming it's a diameter. That is a mistake that a lot of persons who did this question, the year this question was set in 2001, made. They assume that this was a diameter and got the question wrong. You cannot go by how anything looks because it clearly said here, not drawn to scale. All right? You cannot go by how the diagram looks. Remember, if you don't see the center, you don't see a line passing through the center of a circle, you cannot assume it's a diameter. The center might just be right beside it. The center is right beside it, it's not a diameter. It has to absolutely pass through the center to be a diameter. Mathematics is the most exact science. If it's not the center, it's not the center. You cannot go by how the diagram looks. So you have to find the angles some other way. Do not assume anything. Even if an angle looks like a 90, they don't give you plausible reason why it's a 90. Theoretical reason why it's 90. You cannot assume it is 90. Don't go by how anything looks. All right? All right, so let's go. Let's answer the question. It says in diagram not drawn to scale RTSEQ. I mentioned that already, right? So these are two tangents from this point T. It says angle RSW is 50 degrees right here. You must recognize now that this is an angle between a tangent and a chord. So this chord is going to go and subtend the same angle at the circumference here, 50 degrees, all right? And the angle inside is 110. We did that already. And then it's telling us now that these two lines are parallel. And we know that they are parallel by them putting on these arrows on the diagram. All right, so those two lines parallel. Then they ask us now, calculate and give reasons for our answers. And the reasons are the rules, guys. The rules, the 7 rules plus the other geometry rules that we know already. Right? So the rules are not restricted to the 7 rules that we learned during this topic. All the geometry rules apply just the same. All right? So this one says now, calculate given reasons. First angle I want is WQS. Right here, WQS. Where is that? WQS, that's this angle. The one. What angle is that? What angle is that equal to? 50, right? All right, so remember, you want to find this angle now. And don't see right off the bat how to find it. First tip, first hint, first instruction, first guidance, first suggestion is for you to find what is subtending the angle. An angle is either subtended by a chord or by an arc. So you trace back along the lines forming the angle until you reach the circumference right here. It's on one side, and you trace back on the other side until you reach the circumference right there. So this is subtending the angle, which is that chord. What is the chord glaringly doing? It is glaringly making this angle of 50 degrees with this tangent. So since the angle between tangent and the chord right here is 50 degrees, then the chord itself is going to go and subtend the same 50 degrees at the circumference. So it's a tangent and chord rule situation. So the angle here, yes, is 50 degrees. All right? So this angle inside here is 50 degrees. All right? So we can just state it now over here. So it is that the angle that I want, which is WQS, is equal to 50 degrees, only 50 degrees on the diagram. And the rule is the 7th rule that we have. The tangent and chord rule. Right here. Angle between a tangent and a chord equals angle subtended by the chord. So you would have to write out this rule as your reason. Write it out. That is it. That's what you have to write out. Angle, this means angle. Angle between tangent and chord equals angle subtended by the chord. All right? That's it. And I'm leaving this angle in the diagram in case I need to use it. It will help me to find other angles. The next angle I want is angle WSQ. WSQ, where is that? WSQ. That's this angle now, right? And as I said, a lot of persons want to think it's 90. Trust me, the average person is going to believe it's 90. Because they're going to assume that's a diameter. It's actually not 90. All right? So we find it some other way. That's not a diameter. What other way we can find? We can introduce the use of this thing that we know that's an isosceles triangle because the two tangents are equal in length, such that we can find this angle right here. And after we find that angle, we can say total angle of the triangle 180 degrees. But this is the angle that we want, right? Let's look at it. Let's put the calculation on here. We're going to find this angle here first. I didn't ask for it, so I'm putting it in blue. And this angle is the same. So here, I'm going to say that angle is 180 degrees minus this 110 degrees. And divide that by 2, it's going to become 35 degrees. I'm putting the calculation over here. So for part 2, I'm gonna find this angle first. We just did, right? I'm gonna say angle QST. Angle QST is equal to 180 degrees minus 110 degrees divided by 2, which is 35 degrees. And the reason for that is that the total angle in this isosceles triangle is 180 degrees. So that will be my reason for this one. Total angle in, I have to say it's an isosceles triangle, that's why I divide by the 2. But these two equal. I have to say it's an isosceles triangle. Total angle in isosceles triangle, what triangle? STQ. STQ is 180 degrees. That's why I have 180 here. And then now I'm going to tell them this angle that we want now. Using the fact that 150 plus the angle that we want plus 35 down here, add up to 180 degrees. Total angle on a straight line. So if this is 35 and this is 50, I subtract those two from 180 to get the one in here. I'm going to tell the examiner now that angle that we want, which is WSQ, becomes 180 degrees minus the sum of the 50 and the 35 right here. And that becomes 95 degrees. See? Why is the reason for that? Because now we use total angle on the straight line through this point is 180 degrees. Total angle on a straight line is 180 degrees. That's the reason we use for this one. Total angle on a straight line is 180 degrees. That's the reason for that one. All right? So that angle in there now is 95. Let's put them on the diagram. This angle is 95 degrees. This one. The next question asking us for WYQ. No, sorry, WQY. WQY. WQY is this angle in here. Put on that one in purple. So it's not asking for this angle. So how do we process this one now? So this angle now is the angle between parallel line and this transversal line. So remember the Z angle is going to make it equal to this angle in here. That angle is equal to this. But then this angle is equal to the 35 down here. Because of tangent and chord rule. There's a 3 thing happening here. I want to say first that this angle that we want is equal to that because alternate Z angles are equal. And then this angle is equal to the 35 here because of tangent and chord rule. So we're going to have to set it up in a sequential way, right? So the angle that we want here is equal to this one because of alternate Z angles. Let's write that. Part 3. The angle that we want, which is WQY, is actually equal to this angle in here, which is SWQ. Angle SWQ. All right? We can write the reason for that. That's because alternate Z angles are equal. Alternate, what we call Z angles, are equal. So those two equal. And then on this angle, put that back in red now. This angle now is actually equal now to the angle down here because of the tangent and chord rule. So I'm going to tell them now that it's equal to the angle TSQ equal to angle TSQ, which happens to be 35 degrees that we calculated up here already. All right. And why is this? And why is this one? This one is because angle between a tangent and a chord equals angle subtended by the chord. That's what we did, right? Angle between tangent and chord equals angle subtended by the chord. Rule number 7 we use for that. But good with that? But okay with that? Online, by the way, to that?
Yes. Yes, sir.
Good. Putting that rule here, remember, rewrite the rule. Don't try to reinvent the rule. Try them the same way every time. You have any time to go in the exam and be trying to construct a reason in the exam room. Just write it the same way every time from now. So when you go in the exam room, you see it, you write it the same way again. All right? That is it. So that angle is 35 degrees. So that is the answer. 35 degrees right here. All right. So let's put it on the diagram that this angle is 35 degrees. But get into the habit of everything that you find, put it on the diagram. So this is 35 degrees, and this is 35 degrees. Those two. All right. The next angle I want is angle WXY. WXY. The angle is right here at X. We're talking about this angle. This one is opposite to that one in that cycle, quadrilateral. See the quadrilateral here, majority out in green for you. So down this line, that one, that one, that one. So that green quadrilateral is cyclic because the 4 vertices are on the circumference. Because it is cyclic, these two opposite angles add up to 180 degrees. So since this one is 35, then the one inside here that we're trying to find now is 180 degrees minus 35 degrees. It becomes what? 145 degrees. That is it. That's because opposite angles on a cyclic quadrilateral are supplementary. That's the reason for that one. The cyclic quadrilateral rule. All right. I want to tell them that the angle that we want, for Mr. Shaw. Angle that we want, this is what part 4. All right, the angle that we want, which is angle WXY, is equal to 180 degrees minus 35 degrees, which is 145 degrees. And that's because of rule number 4, I think, cyclic quadrilateral. Yes. Remember, when you write in the cyclic quadrilateral rule, you have to put the word opposite. Right here. That's it. That finishes that question. Always say, but I that. But good?
Yes, sir.
Yes, sir.
All right. So what you're gonna do for me now? I'm gonna give you a couple minutes to do this one, and then I'm gonna do it, right? Some of the classwork is represented. I want to do this one for me that's on the screen. And I'm gonna look for the one that I'm gonna be doing next as well. So this one for me now that's on the screen. I'll give you a couple minutes to do it, and then I'll do it. What time is it? 6:25. Let me give you 10 minutes to do it. 10 minutes to do this one. Come on. Look at it carefully. All right? And do it for me. This one right here. What you have parallel lines in it and so on. All right, let me find the next question I want you to do as well. 2019. 2019. Question next. This question wants. Those who finish that one can do this one. This question wants this angle ETR wants angle TPQ, right? So part 2 wants angle TPQ. And the third question wants TPQ. And I also want angle POR, or just in that circle, part 3. Angle POR. We always the center of the circle. They didn't show the center on the diagram, but it was the center of the circle, right there. Bracket, always the center of the circle. All right, so those who finished the one over here can try the one over here as well for me. Finding these 3 angles in the diagram. This is angle. This is let me write over it. Angle PTR. Angle PTR. Angle PTR. Angle PTR. Right, those 3 questions are going to do for this one. Everything they say appears in the diagram, so I don't have to show the diagram. All right, that is it.
word we, and it's we 110 pounds. We, so the word we. This is we. This is we.
No.
So
The laptop.
I'm gonna say exactly spell the word we, spell the word we. That's we. Spell the word we. So I mean we, they have we, there's something. Spell the
Anybody online finish? Anybody online finish? Nobody finish? Anybody inside here finish?
No, sir.
Finish? All right, so this is not the classwork now. Just wanted to give a shot at it. All right, and I particularly pick those two questions for a particular reason. So not every time some of the things are going to be clear. The basic principles remain the same. All right, let's look at this one now. Let's look at this one first. So basically everything on the diagram is written up here, right? All right, these two lines are clearly parallel. These two lines are parallel. And this angle is 53 degrees. Watch this now, guys. Pay attention. Pay attention. Now, one thing I want you always to observe and remember is that the triangle formed from the center, the circumference here and so on, or the triangle in a sector of a circle. I'm not mentioning it as a sector triangle yet because we don't do that topic. We're doing that topic next week. But the triangle formed from the center point here, that will always be an isosceles triangle. Why? Because this is a radius and that is a radius. The triangle form between two radii from the center will always be an isosceles triangle because, as I said, those two lines are radii. Each of them is a radius. So that triangle is isosceles. So in this isosceles triangle, we are blessed. These are the two equal sides. So these are two equal angles down here. All right? The angles opposite the equal sides are the equal angles. And once you know one angle in an isosceles triangle, you're blessed because you can find the rest of them. All right? So before I even start doing anything, this angle is 54, so this 53, so this angle is 53 as well. All right? And so I can find these two angles easily from this one because this is an isosceles triangle. Another thing you must recognize now is that because this line and this line parallel, you have this line joining them, and so you have Z angles here and here. Now this angle happens to be the angle at the center. But those two angles equal Z angles. Again, those two parallel lines are also connected here. So I mean that this angle down here and this angle inside here, they are equal. They are alternate Z angles. Good. Let me show you one more interesting angle. This angle right here is already right. This angle right here is an angle at the center. If you come back along the lines forming until you reach the circumference, then that angle at the center is subtended by this chord. If you don't want to use a chord, you could say this arc. Remember, it's an arc or a chord that subtends an angle. This same chord that is subtending this angle, the circumference, is now subtending with a different color. This angle out here, sorry, at the center, is now subtending this angle out here, the circumference. Center rule says that one at the center is twice. Whatever this angle is, it is 2 times this angle. For example, if this angle inside here, so let's put a number on it. It's 50 degrees. Then this one is 25 degrees. All right. So That is the trouble, seeing some of the angles in a diagram like this, where you have to practice to see them, because it's the same basic concept. Follow the process, go back from the angles and find the chord. Look what the chord is doing. Something angled circumference. This one is at the center. Center rule says the one at the center is twice. All right, let's answer the questions in the sequence that they gave us now. All right, just wanted to just run through it a bit. All right, let's what angles do they want first? They want angle POQ first, angle at the center there. That's here. As I said, you have to first recognize that this triangle is isosceles. To do that, but then it means that this angle down here is also 53 degrees. This one is 53. And so the angle in here that I want is 180 minus the sum of those two. Right? This angle is 180 degrees minus 53 and 53. So you're subtracting 106, you get 74. This angle is 74 degrees. But I go to that. All right, so this angle inside here is 74. Let's put down the diagram. I like to put angles on the diagram. This one look kind of cumbersome, but let's put it on there still. This angle here, I can't even make it any smaller. This angle here is 74 degrees. That is 74 degrees. All right, what angle do I want next? I would say this one is 53. In here is 53. What angle do I want next? So we'll do this one, 74. This is the second one. OQR. 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 That's the one down here. A center road enough. Right? So as I said, this 74 is at the center, subtended by this chord. The same chord is subtending this angle up here at the circumference. One at the center is twice. So this one is 74 degrees divided by 2. 74 divided by 2 is 37 degrees. Reason for that is that the angle at the center is twice the angle at the circumference, subtended by the same chord. That angle is 37 degrees right there. But good so far? But okay?
Yes, sir.
All right. So this one inside is 37 degrees. Study the rules, guys, and practice them. 37 degrees. And every time the diagram is going to be very clear. We still have to follow the basics. All right, which angle do I want next? So we have two angles so far, this one and that one. Next one I want is angle PRQ. We don't use the angle yet, you know. Angle PRQ, where's that? That's what we just found out a while ago. PRQ. Where's the wrong angle found? Found PRQ a while ago. Down here. Oh, so we just found this one. We just found this one. We don't find this one yet, which is OQR. Okay, all right. So the one is up here. OQR is this one. Let me use a different color. So another one, OQR. That's this angle inside here. But that one equals 74. Can you see that? Because of the Z, right?
Yes,
Here,
sir.
parallel line, good. Z angle is equal. So this one is 74 as well. All right. So that one is 74. 74 degrees. Alternate Z angles, right? Those two angles in the Z. This one is 74 degrees. I'm gonna say Z angle. The next last one I want is angle QPR. 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 So talking about now down here is a different color for it. Q to P to R. That's this angle the one between these two lines. Now that angle, let me show you what I would look at that angle. I would look at this complete this triangle. A purple triangle. And that angle QPR is one of the angles in that triangle down. So that QPR angle can sum these two plus this. Subtract that from 180 to get the QPR angle right here. But I can see that. Let me take out some of these and show you. All right, so asking us to find this angle right here. So I'm saying what we could do, we look in this triangle. The purple triangle. And the total angle in that purple triangle is 180. Just that this angle across here is the sum of the 53 and the 74. Across here, this angle. So these are the three angles in that triangle. Add up to 180. See that? Just that this one over here is the sum of 53 and 74. So then this angle here that they want now, this last angle that they want here, it becomes 180 degrees minus this one down here is 37. And this one over here, this one here is the sum of the 53 and the 74. So you're subtracting them to them as well. 53 and 74 degrees. Whatever that work out is the answer for that one. All right? But all right with that? Online, everybody good?
Yes, sir.
Yes, sir.
All right, let's jump over to this one now. I'm going to give it a classwork after this. So I just wanted to see this example because a lot of time we tend not to see when an angle is obtained by an arc. As most questions, you see the chord. Ever so often they give you one obtained by an arc. And there's one additional rule in this question that it is good to know, but not absolutely necessary. So I don't give it as a part of the class up front. But it's a good rule to know still. We don't absolutely need to know. You know enough to find the angles in it. But I'll show you still. So everything appears in the diagram. Everything that they have set up here is on the diagram. So I don't have to waste time and read that, right? In this question, they have not shown the center. You cannot assume that that's a diameter. You cannot assume that that's a diameter. They have not shown the center. That's a mistake a lot of persons made in this question. They assume that this point was a center. It not even look like a center. But that's what some people do. Because they assume that these were two diameters, which they are not. The question didn't say anything about them big diameter. All right, so everything is there on the diagram, right? Oh, another mistake some person made, they treated this like it was a tangent, guys. Not a tangent. Right? If cross a circle, it cannot be a tangent. A tangent touches at a single point only. So you cannot see this as a tangent. All right? That's another mistake some persons made with this question. They were seeing this as if it was a tangent, but it's not a tangent. All right. So the first question is first to find angle PTR. Let's mark it out with a red. That's this angle up here, PTR. That's this angle one. As I always say, if you cannot see what that angle is right off the bat, find a chord that is subtending the angle. If there's no chord, there must be an arc subtending the angle. So you find it, you come all the way back along the side, forming the angle until you reach the circumference. So you cannot, for example, come and stop here, so. I cannot come and stop here, so. And so, okay, this is the line subtending. No. Talking about chords and arcs subtending the angles. And so you have to come all the way back until you reach the circumference to find the arc or chord subtending angle. So this angle is being subtended from these 2 points. There's obviously no chord given on the diagram there. So it has to be that it is this arc that is subtending the angle in this question. Draw the arc in blue, this arc running. Now that arc is subtending another angle from these 2 points in this diagram. That's this one up here. So that blue arc is also subtending this angle up here. These 2 angles are in the same segment if you were to join these 2 points with a chord. This will be the minor segment. Over here is the major segment. That's a same segment rule situation. These 2 angles are in the same segment. They are subtended by the same blue arc. So they are equal. So this angle over here is 75 degrees as well. All right? Good. So angles subtended by the same arc or chord. All right? So let me put in the 75 degrees here. And you would say angles in the same segment are equal. All right? The next question says, we have to find angle TPQ. TPQ. Let's trace it out. TPQ. That is this angle, the one next. So that angle happens to be one of the angles. Because if you trace it back in, you're getting this big arc. But this arc not subtending anything else in another quadrant, in another segment, right? But it's one of the angles in this quadrilateral, which is cyclic. This is an angle in this quadrilateral, which is cyclic. So it is opposite to this one over here. These 2 angles right now are up to 180 degrees. But this one over here is a different color. This one over here is on a straight line that is completed with the 60 degrees. Total angle on a straight line is 180 degrees. And so since this half of the angle, or this piece of the angle is 60, then the remaining portion of the 180 must be 120 degrees. Then now, these 2 opposite angles are supplementary. And so this angle over here is 60 degrees. And so this allows us now to introduce a 8 rule that I did not give you. That you don't absolutely need to know. If you notice, we found the angle in now. But look at this rule where you could use if you know it. It is that the external angle of a cyclic quadrilateral is equal to the opposite interior angle. That's another circle rule. An additional one that you don't absolutely need, but the more things you know, the better. So look at this red cyclic quadrilateral now. But this side, this angle over here is really an external angle. Why is it an external angle? God is an angle between the extension of one side and the side adjacent to it. It's an external angle. That external angle is equal to the opposite interior angle of the cyclic quadrilateral. So this angle is 60 degrees over here as well, by that rule. So the external angle of a cyclic quadrilateral is equal to the opposite interior angle. This is the interior angle of this one. Opposite to it is over there. Right? So you could use that rule as well. This angle over here is 60 degrees. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. That's a number 8 rule. 8-1. If you want to write. All right, the recording is there. You can always listen back the recording and say it. Right? It's in the textbooks, as some of the textbooks as well. So that angle down here is 60 degrees that I wanted. All right. I'm going to show you 2 ways to do it. All right, the last part now is angle POR, where O is not shown in the diagram. What I would do in an exam, I'll take this off to make it more glaring. Put on a point O So you cannot try to locate where the center of the circle is. Put on a point O, looks like around here. And I would draw in that angle that I want. POR. That's an angle at a center, guys. O is the center. Once you have an angle at a center, you should be thinking about the center rule. Angle at center is twice the angle of circumference. All right. So this angle at the center right now, again, is subtended from these 2 points on the circumference. There's no chord shown there. If you like, you could put a chord in the diagram as well. And so that is the chord subtending this angle at the center. The same red chord is subtending this angle at the circumference up here. Which is 75 degrees. Or you could use the other one over here. Still 75 degrees. The center rule says the one at the center is twice. So this one is 2 times that one. Times that one by 2. Yeah. One at the center is twice. So the one at the center has to be 150. I said that. So even if you did not put in a chord, you have to be able to see that the arc is subtending the angles as well. Right here. This arc. From these 2 points are subtending these angles up here at the circumference. The same arc is subtending this angle at the center. Angle at the center is twice, so this one is 150. 2 times 75. But all right with that? But good? All right. I'm gonna send the classwork. I'm gonna send the classwork and I'm gonna put up a classwork on the screen. I'm gonna give you guys it physically in here. I'm gonna send it in the group as well. I'll put up on the screen and you can screenshot it. There you go. 2 questions. That's the classwork. 2 questions. All right. I'm gonna send it in the group as well. All right, I just sent it in the group. All right. You want the paper? You got the paper for you guys here. Start work. People online, when you finish your work, you send it to me directly. Don't send it in the group. Send the work to me directly, please. People online. Huh? Forward number. Work. Huh? Yeah, for the rule, for the reason. Everybody remember you have to write the reason for your answer. See it here. You have to write the reasons for your answers. And as I said, don't try to make up a new rule or create no new rule yourself. Write one of these. Right? The rule must be just written simply, like what I have in red on the screen. Don't try to reinvent the rule or try to rewrite. Just write the rules the same way every time. Those are the rules. Those are what you use for your reasons. Right? Those are the reasons. Alright. Guys can go home now. They'll come, I didn't die. Thought you were gonna die, don't? Huh? Yeah, you didn't die. Huh? Hmm? Mm-hmm. That's the only reason why this is 24. This is not the exterior angle. Let's start. So an exterior angle is a one tangent. That's not the exterior angle. The exterior angle is formed may extend the side that's on the by may extend the side that's on the quadrilateral. Let me show you exterior angle. So got this one. They come have this quadrilateral right here, so show it where you classify as an exterior angle. Exterior angle must be an extension of a side. Right? So if I have this quadrilateral right now, right? And exterior angle is if I take one any one of those sides and extend it. I suppose I take this one. Extend it out right now. The exterior angle would be this. Alright. What will be the exterior angle? But this is not an exterior angle, like a tangent. Right? Right. So what you have here, a tangent and a area. So yeah, what is this angle between? This angle between what? What is that? What is this? What's this line? And what's this line? You have an angle between a tangent and a chord. So look on a rule there. You have to know the rules them. You have to know that a tangent and chord will exist. You see this? NKL. It's not right either. What them? All right. I don't know, right? But the angle right, but the reason wrong. So an isosceles, I'm tell you this one isosceles triangle. Look, this one they say them two lengths are the same. Two lengths are the same now. You see, it's a little mark I'm telling you about today. Little mark on this one, mark on that one. But I said it here as well. These two lines are the same. That's an isosceles triangle right there. Mm. Now you center rule, I don't know where the center is, mom. Where is center rule? I don't. Where's the center? You have to even know where the center is. You can't be center rule. I don't even know where the center is in the diagram. And I don't want you to state no rule like that. You can't put that on the exam paper. You have to write out what is in red. That's what I keep saying. You have to write out what is red. This is just our little way of remembering them. That are over here. We have to write out these that are in red on the exam paper. You can't say center rule to the examiner. The rule and name, so we just call it that in our class. The rule and name diameter rule, we just call it that in our class so we can remember it. You cannot write these. You have to write what is in red. This angle is correct, but you have the wrong reason. This angle is correct. Good. This angle is correct. We have to write the reason. You write the right calc, but you have to write the reason. Question said it. It says stating reasons. Stating, me have to write it out. That's what it's saying. No, stating reasons for your answer. You have to write out the reason. So I give you these ways of writing what the reasons in addition to the other things we already know. Total angular triangle is 180. Total angular straight line is 180. Alternate angles are equal. Co-interior angles add up to 180. Those other rules also come into play with these questions sometimes. Total angle in the isosceles triangle is 180 and two other angles them equal. Stuff like that. So that one you know. You can't just no, you have to write it to go and write them out. No shortcut. Well, do the work and sense. Oh, you got a while ago? You want to see if you gonna? Look if she drive out. You buy it from her? I think everybody who didn't come live a Spanish town. Gonna finish it. Oh, well, this you have to write the reason for this one as well. And put on the angles then for me, please. You lose marks for leaving out the angles and put on the angles. Go on. Anybody online finish? Then send it to me, to the group. Send it to me on WhatsApp. Hmm? Yeah. It's 132. Mm-hmm. Let me see how I say now. All right, good. Yeah, but we have to show the right. Yeah, and show the calculation and the reason why it is that. Yeah, sometimes I'm gonna minor calculation, but you have to still show it. They want to get the marks in. Damn to that straight line. Peter? Hold on, let me try something on. Put on the degrees them. Put on all the degrees. What is it? Put on all these. Put them on. Put them here. Until the last part done, so this. Explain why this is a cycle quadrilateral. This. You forgot the reason for this one, yeah? Hold on. There is, where the angle there? Where this turn 132? Where you put this as 130? This, where it is? I put as 130. Why put as 130? Oh. LMN. Correct down. Write this answer. This one, I write this. Why is this a cycle pattern for this thing? So that angle access this channel add up to 180 degrees. So that angle access this channel is 180.
Call me back tomorrow, please. Thanks. Please, sorry, I missed you. Call me back tomorrow, please. Thanks.
Which one? Which one? All right. That's not the right reason. That's not the right reason. He's not on a circle. Try again. Hmm? Hmm? You tell me what you think. Tell me what you say. All right, there are two ways of quadrilateral camber side. What are the two ways? Camber side. So four vertices of a quadrilateral and the circumference of a circle inside, right? The other way, camber side. There's no circle on it. But must have vertical side. What's the other way you can decrease that side? Hmm? Yeah. So a quadrilateral with the opposite angles are up to 180, then this is side. Once opposite angles are supplementary, then it's going to be cyclic. All right. This one a tangent concord, my boss. On this one. Angle here, sir. What is this? What is that? It was tangent and chord. Hmm? Yeah, but you put the wrong reason. You say angle between tangent and chord equal 90. All right. You see that tangent? That's the radius. And between tangent and chord equal. So this one, all right. The right angle with the wrong reason. No, right on. All right. Students online, I'm going to end the session now. Just send your solutions to me and I respond to them. All right. I might reply with a voice note or I might reply by marking on your work or something. But send your work to me on WhatsApp. Okay, students online, but I'm going to end the session now. Everybody hear that? All right, I'm gonna end it now. Send your work to me. All right, buddy. All right, cool. Yeah. Hello. Good night. All right. So question one, first answer is correct, but you did not put a reason. You have to write your reason. Same thing for the second question. You answer the question, got the right angle, but you did not put a reason. You have to write down the reason because the question clearly said stating reasons for your answer. The third part of the question, and we got what, 48? Yes, 48, yes. But again, you did not show a reason. You have to state a reason. All right, state a reason why that is 48. Second question, angle OAE. No, that's not 45 degrees. OAE, look back at it. That's a tangent and a radius that you have there. And angle OAB. No, again, that's not right. Because you have the 48 degrees and the two tangents and the two radii is a cyclic quadrilateral. All right, so check those over and send me answers again.